So here we are in the PE1. Let's deep dive the forwarding, how the forwarding we have. First check what are the routes as we are using the VRF blue on both of the P. Let's check what are the routes we are getting in the VRF blue. Okay. So here we have a routing table for the VRF blue. In the VRF blue, with the help of BGP, this prefix we are getting. Let's check the BGP table for this prefix. BGP for unicast, VRF blue, and let me put this prefix /32. Okay. This is the prefix and this is the next hop. This is the IP address of our 2.2.2. This is the IP address of PE2, provider edge router 2. And here we are seeing the binding CD attaching 24004. Okay. This route is coming from 11.11. This is the IP address. So route reflector is reflecting this route without changing the next hop change. As we have configured the next hop and change on the RR. So this is the RR IP and this is the received label. This is the BGP VPN V4 label. Okay. And this is the color community we are attaching. Okay, as we have seen the configuration. Let me again show the show running router BGP. So this RPL we have applied. Show RPL route policy view. What we are doing is if destination is if we get the destination, if we get this route, we have to attach this policy. So that's the region. This color community extended community is attached. SR policy color 100 is attached. Okay. So here it's configure show RPL and build community. So this one. This is the action set for this prefix. Action set 100. This is the region we are able to see here. SR policy 100 is gone. Okay. This thing. So now we can see that let's check SEF also. Show SEF. VRF blue IPv4 for 222.222. So this is the prefix connected behind the provider H2 route. So what it's saying is this prefix, okay, via local label 24004, and we can see that here the next hop is SRT segment routing TE, and label involvement is implicit null and 24002. 24002 is the receive label as you see. This is the VPN label, and next hop is showing the interface. And if we check the route, normal show route VRF 2.2.2.2.2.2. It's showing this route is coming from the 222. If we check the route, show route, and in the next hop in VRF default 2.2.2.2.2. So we have configured the static route here as we are not doing any stitching, we are not exchanging the service provider loop back. So we have configured the static to make the route eligible in the BGP table. Show run router static. As the next hop was the unreachable, as we are not exchanging the BGP, this service provider loopbacks, zero addresses. To make the route eligible in the BGP, I have put the router static address family with respect to null. After that, this route become the eligible route, or we can say the valid route in the BGP table. Okay. This is a table. So what's happening here is, as we can see that from this output, when you run this command, it's saying the next hop is SRTE, segment routing T. So let's see the segment routing configuration here. Segment routing traffic engineering. What we have done is, in the segment of traffic engineering, we are doing the on-demand color, which we have attached the community, extended community, attached the prefix in the 222. This PE1 router is acting as a path computation client. This will request the to reach this prefix, this color, if color attached to that prefix, so it's requesting this part to the PCE. This is the path computation element with our controller. So controller have to make sure that we can see that in the traffic engineering we didn't configure any explicit path. So we will ultimately we get the dynamic path from the controller. So let's see show segment routing traffic engineering policy. So here we can see that requested binding seed is the dynamic. Okay, this is the preference path BGP on demand active, and this is the PC path computation client info. So this is the path we are getting from the PC path computation elements dynamic PC. PC is the this is the RR, as I have already told, correct. RR is RR, both the route reflector RR1 and RR2 acting as a performing two job. One is the route reflector job for the VPN before address family. Second thing, they are also acting as a controller, PCE. So PCE sending is the this information. This is the label stack is sending to this client to reach this prefix triple two dot triple two dot triple two. We have to attach these three label stack. First thing, we have to send this traffic to the ASBR2. This is the ASBR2 node prefix. After that, this is the EP label where we have configured the BGP egress peer engineering between the ASBR1 and ASBR2, or we can say the urgency seed. And after that, this is the final node seed for the PE2. So this is the thing we have. And okay, so let's do trace route. Trace route, we are blue triple two dot triple two dot triple two dot triple two slash. There's no need to source triple one hour IP. Bad host, I'm sorry, wrong IP here. So three label stack is imposing, as we can see that this is the label stack. Let's verify segment routing TE traffic engineering on this section also. So run segment routing. So run segment routing traffic engineering. Here we have defined the segment traffic engineering ODN. If we have a color 100 is matching with any prefix, so this as PE1 is acting as a path computation client, so this will request the path, dynamic path from the PCE and metric type for the path computation to the IGP. Here we have configured the controller IP. So for this PE1, this is the PCE server path computation element we have configured, and we can also check show segment routing traffic engineering PCC is stated up or not. Let's check show IPv for PA. Here we can see that checking the verification. Which are the messages going on, and here we can verify this client having a status up with the controller with the PCE. And let's check this is what are the LSP. The question mark. So these are the what are the LSP information we are getting from this controller. So we'll be able to see that this controller which we have configured 11.11.11 is sending this LSP information. This sending LSP from the source, our address and destination. So between this PE1 to PE2, this is the LSP information label switch path information is sent by the controller. So this is the binding seed is there, setup type is segment routing, and this is the seed list. This is the seed list which is shared by the controller to the our client PE1. PE1 is the client here. So let's do the trace route now. Trace route VRF blue two dot triple two dot triple two dot triple two source. Here we have so same label stack we are using while forwarding the traffic. So this is our inner label is GPN label, and this is the label for the P2, and outer label is EP label. Our the EP means the interface agency seed, or we can say label with the interface label between the ASBRs. Let's jump to the PE2 also. We'll do the similar kind of verification. After that, we'll do the verification on the controller, both the RR. This is our PE2 node. Login. Let's quickly check the segment routing traffic configuration also. Here also config same. Again, we are requesting for this color path from the PC path computation element. This is the IP address of for this domain. This is the second PCE. Again, RR2 IP address as RR2 also playing the two job. One is the route reflector role for the VPN V4 prefixes. Second thing, acting as a path computation element or the controller, we can say. Similar way, we can verify all source segment routing, traffic engineering, PCC, IPv4, peer, where we can see the state is up. Okay, and also here we can also check LSP information also, traffic engineering, then PCC, LSP. So here we are also getting the from this source, so from PE2 to PE1, we are getting the LSC information. If we go the detail, we are able to see the label stack information also. Again, this is the 24001, and then this is the 24004, and these are the two other agency seed, and what is the final PE1 loopback 0 IP address 1.1.1.1. Similar way, we can verify here also. Let me show you the quickly PGP configuration. As you seen earlier also, here we are also attaching this RPL. This RPL is triggering this get segment routing PE. In the RPL, we are matching. This is the customer prefix which we are getting from the PE1. We check the route, show route VRF new prefix. This is the route we are getting from the PE1. And on this PE1, we are attaching show BGP, VPN V4, unicast, VRF new. While receiving the route from the RR, we are attaching that RPL value in that RPL, setting the color community 100, and when the color community in place, that client this PE2 requesting a tunnel information, path information from the controller from the RR2. RR2 is sending the recipe information. After that, forwarding is happening. Do this here also trace route VRF blue 111.111.111.111 source from the loopback. So we'll be able to see that same stack, same level stack we're seeing as you see. So segment routing, traffic management policy. It's the forwarding policy. So we can say this is the stack, this is the binding seed it's showing about. We have here it is. Binding seed in place. So this is the trace out we have done. We have verified the states of the PCE job. Let's jump to the RR. Let's run some verification command on the RR. We can see on the controller also. Check the show PCE IPv4 here. With this command, we can verify with the client state is up or not. We can see that state is up. Let's check the here also show ISS segment routing. So segment routing. I do traffic in show segment routing. PCC V4 then here. Sorry, what was it checking? This is not, I think. No, this is the client for the client actually we have seen correct enough. So we can check the BGP link state summary, where we can see that these are the database routes link state information getting from the RR2. And the show BGP link state. We see which the neighbor. Our neighbor is 33.33.33. neighbor, I can say the routes. What are the routes I'm getting? So here we can focus. So this is the P flag is for the prefix. Here we can see that we are getting the route of the PE2 loopback. Correct. This is how database look like. So this is the information we have on it. And that's it from the RR. And similar way we have in a two neighbors. Second is the our ASBR IP is 22. Yes, 22. So these are the local routes. So this is the local route we are getting from the ASBR1. If you see the route from the 33, here we can see that these are the net IDs. This is the net ID we configure in the ISI. Basically, this is and this is the P flag is for the prefix. This is the prefix, like this is the interface IP is coming /30. These are the loopback IP are coming. So now both the controller have an end-to-end view of the all of the topology. And as the client requested the path, so this controller is sending the seed list, and with the help of seed list, PE provider devices are imposing the label stack on the packet and sending the and getting the end-to-end forwarding. To recap this, as we have seen that end-to-end, what is the configuration we have done and how we are getting the end-to-end reachability. To recap, what's happening is once we have this BGP VPN v4 and BGP link state peering in place and other config required for the PCC and PCE in place, what happening is when like in this example, this is the customer prefix behind this PE2. PE2 sending this prefix with the help of BGP VPN v4 address family to this RR, and this RR further dividing this route to RR1. So once this RR1 will receive this route, as on the RR we doing the next of unchanged. Once the prefix will receive on the RR1, this prefix once we reach to the RR1, the next stop will be the this PE2 loopback. For this prefix, triple two dot triple two dot triple two dot triple two in VRF value, next stop will be the PE2 loopback with the 2222. As we are not exchanging the infra loopback, so this route will not become the valid route and this route will not store in the routing table. To solve this issue, what we have done is we have configured the route static null route for this PE2 loopback on RR also, and after that on the PE1 also. Same way in the vice versa, for the PE1 loopback with the 1.1.1.1, we have configured the route static null route on the route RR2 and PE2. Once we have this route valid and routing table, so what we have done is while receiving this route, while getting this route from the RR, in the invert we have defined the policy. In the policy we have attached the extended community color 100. So that basis of color 100, what's this PCE is doing? Once it's receiving the prefix with the intended color, so it's requesting a path, end-to-end path with the controller, and controller is sending the requested path with the label stack, and after that P is able to get the end-to-end reachability for the customer prefix. Same way we have done the config on the both side PE1 and PE2. On the PE1 we have attached the color 100 for this prefix. On the PE2 for this prefix we have attached the color 100, and the same the color 100 we have requested a path from the controller. Here in this first domain, RR1 acting as this is providing this path, and in this domain, this RR2 is acting also as a controller. So this will provide the path, and we are able to get the end-to-end reachability for the customer prefix.